All right, so our last point, home stretch here. We are going to do point A. So here it is. Here's point A. And we're going to say that we've got this reaction force here. We've got that reaction force A. And we already know, we look at our scoreboard here, we already know it's 25 newtons going down. So we're going to come over here and we're going to say RAY is 25 newtons. And going around the park here, we've got AB, force AB. We also know that's up here on our scoreboard already. We know that, 16.67 in compression. So it's in compression, which means it's pushing against point A. So I'm going to put that there and say it's pushing against point A. That's force AB. And we know it's 16.67 newtons. Okay, now we've got this diagonal, force AD. And again, we're not going to put the diagonal in our free body diagram. We're going to put the component forces. And I don't know if it's in tension or compression, so I'm going to guess. And we're going to assume that it's in tension. Okay, we're going to guess that it's in tension. So it's pulling away from point A, which means it would be up and to the right. That's what we'd be pulling away from point A. So for the x direction, it would mean it's going to the right. So FAD in the x direction would be, we're guessing, is going to the right. And if it were going up, FAD in the y direction would be going up. That's just our guess. As always, sum of forces in the x direction must equal 0. And sum of forces in the y direction must equal 0. Let's see if this marker has recovered any. So we'll do the x direction first. FADX is going to the right. That's our guess, so we're going to leave that positive. FADX. And FAB we know is going to the left, so we're going to put a negative sign on that. 16.67 newtons. We know that must equal 0. So we're going to add 16.67 to both sides. And we're left with FADX equals 16.67. The number's positive, which means our guess was correct. FADX is going to the right. It is in tension. So we're going to go ahead and add a T there just to write it. Okay, now I actually had already written that answer up here. So FADX 16.67 newtons in tension. I had to re-record this part because I goofed up. So that's my forces in my x direction. Now forces in my y direction, I don't actually need to do this one, but we're going to do it anyway because we want to make sure that we've got everything. Everything that's acting in the y direction, we've got RAY is going down, so that's going to have a negative sign on it. And I know that's going down already. And then FADY, we're guessing. So we're guessing that it was in tension, so we're guessing that it's positive. FADY equals 0. So we'll add 25 to both sides, add 25, and we're left with FADY equals 25 newtons. Come on, marker, you can do it. 25 newtons. The number's positive. There we go. Which means our guess was correct here too. We guessed correctly. It is going up. It is in tension. And that's unsurprising because they're both components of a diagonal. So if one's in tension, the other one's going to be in tension. So I wrote that one in here too. So FADY is 25 newtons in tension. Okay, so we have one left to do. We have one little thing left to do. But to do that one, it's a diagonal. So we have to go back to our component forces. So we'll grab our component force back out, grab a fresh sheet of paper, and we'll say, all right, so here's our diagonal. And we know this is AD. Now, where I do my component forces, I could do it below the diagonal or above. It doesn't really matter. The only difference is if you did above this diagonal, we don't know this angle right here, this top angle. I mean, we can figure it out certainly because we know 56.31, and we know together that would make a 90. And so this would be 90 minus 56.31. But let's go ahead. We've been given an angle. Let's not look a given angle in the mouth. And let's go ahead and use what we've got so we don't give ourselves an opportunity to make a mistake. So this is going to be FAD in the x direction, and this is going to be FAD in the y direction. And we actually already know both of them. FAD in the x direction is 16.67 newtons. FAD in the y direction is 25 newtons. And we're trying to figure out FAD. So our choices are sine, which is opposite over hypotenuse, sine theta. Cosine theta, which is adjacent over hypotenuse. Now tangent's not going to help us because it's opposite over adjacent. That's not really going to help us, right? We know all those already. So sine or cosine, let's go ahead and use cosine just because we didn't use it earlier. So cosine of 56.31, that was this angle right here. Cosine of that equals adjacent over hypotenuse. What's the adjacent? Well, that's this one right here. So 16.67 newtons over the hypotenuse, which is FAD. I'm going to multiply both sides by FAD and divide both sides by cosine 56.31, essentially swapping these two. So FAD is equal to 16.67 newtons divided by cosine 56.31. Break out my calculator one last time, let's hope. And, oops, that's a little reflecty. Yeah, we'll go right there. 16.67 divided by cosine 56.31. And I end up with an FAD of 30.05 newtons. And again, I know that's in tension because the component forces are in tension. 30.05 newtons in tension. There is our entire scoreboard. It was a long journey, totally filled out, top to bottom. All the values are there. In the last and final video here, I'll go ahead and check this against the MD solids that Adam did, and let's see if we were right.